Hi, yeah, I am Dave. I'm on Twitter at Rambling Dave, but don't particularly follow that for tech stuff. It's more sort of what beer I've been drinking recently and stuff like that. And I've been a full-time Pythonista for about 8 years. My employer is paying for me to be here, so I thought I'd give a quick plug for them. They're called Transversal. They're a medium-sized firm based in Cambridge. They produce knowledge solutions or knowledge management solutions for customer support. And if you want more details on what that means, talk to me later, really. And we're hiring, but we're hiring C++ devs rather than Python particularly. So I think I'm going to start this talk with a statement which is reasonably uncontroversial these days. Tests are good. Tests help us to catch bugs. They also give us the confidence when we're refactoring that we're refactoring without changing stuff. But like a lot of people, I sometimes find that writing tests is hard. I write some tests and I test it because I'm not practicing test-driven development. And then I find myself scratching my head a bit and wondering how I'm actually going to write the test for this bit of code, or spending a lot of time writing things. And sometimes the answer is I just need to think harder about it. I need to maybe use a better testing tool, or I need to think about sort of how I'm writing the tests. But sometimes I'll look at it and think, actually, the thing that I need to do here to make this testing easier is to change the structure of the code a bit. And often when I do that, I find that the result is not just that it's then easier to write the test, but I'm also actually a bit happier with the code. I think the code is then better. So I guess the basic topic of this talk is the idea that testable code is better code, subject to some terms and conditions. And hopefully, if we kind of get into this way of thinking, well, I've found that getting into this way of thinking then helps me to write better code by thinking about how I can make it testable. So the basic structure of this talk is going to be, well, first of all, I'm going to talk about why I think this is the case. I mean, it's a reasonably non-obvious proposition to just state. It's a thing that I've kind of found in practice, but I've had a bit of a think about why I think it might be the case. I'm then going to give some examples to kind of illustrate how you can apply this sort of way of thinking when you're struggling to test something, and then just kind of wrap up and summarize. So, why? As I say, I've found this to be a correlation, that sometimes I make code testable and it ends up better as well. But that's not really entirely convincing itself. Why do I think it happens? Well, what do we mean by good code? So often, good code, two things that we want from it are that it's understandable and it's reusable. And reusable can mean that you can take that same bit of code and apply it somewhere completely different. It could mean that as your use case evolves, you can change the code without it being without sort of getting bogged down in the difficulties of changing it. These aren't the only things that make good code. They aren't always things that you need in your code. So everything I'm saying today comes with a massive disclaimer of use your judgment. It's not a kind of a direct causation. You can't just blindly apply this to any kind of principle. You always have to think about your situation, but it's a thing that I find happens often enough, and that these are things that we value often enough, particularly in big long-term projects, that it seems to be a useful thing to think about. So that's good code. What about tests? Well, for this purpose, there are many kinds of levels and sorts of tests, but I'm really talking about unit tests. Unit tests are written by the developer, generally at about the same time that the code's written, either slightly before or slightly after. They test a small amount of code in detail and in isolation. And the isolation is actually quite important here. Ideally, a unit test will fail if and only if the logic that test is meant to test is wrong. It won't fail if the internet's gone down, or if the database hasn't come up yet, or if someone's changed something somewhere else in the code base that shouldn't affect the logic that you're interested in. In practice, that doesn't always happen, but that's the kind of the ideal that we aspire to. So when we come to write a unit test, what we do is we look at the code and we think of something the code should do or shouldn't do. We run the code in a test harness, and then we check that the code does what we think it does. So we check the output that comes from the code when we've run it with a certain set of parameters, and check that's what we expect. So we're thinking about what it does and then running it in a test harness. So essentially what we do when we test code is that we understand it and then we reuse it. So possibly the reason that sometimes code is hard to test is either because it's hard to understand or it's hard to reuse, or both. So I think that's why you will often find that if you're struggling to test code, there are also things that you can improve about it to make it better code. So, examples. This isn't meant to be any kind of definitive catalogue of ways of writing good code or to kind of exhaustively show everything that you can do. It's more examples of how a thought process goes. So I'm basically going to give a series of problems that I will hit when I'm trying to write a test, and then give us an example of some code where I hit that problem, generally either cut down or toy examples, and then explain how you can think about this, solve that problem, and hopefully end up with better code. So the first one is quite simple. I don't know what to test. I don't actually understand what this code is meant to be doing. This sounds like a silly problem to have, but to me it happens more often than I'd expect. Often if I've got some code which I've evolved over time to perform a poorly specified task. So an example would be if I've got some code which is meant to clean some input data or input text. And the way I've written this is that I started off with some text and I just tried running a processing task on it and got weird results. And I realized that, actually, it's partly giving me weird results because it's got lots of different sorts of Unicode spaces in it, or the spacing is inconsistent, or there are lots of blank lines that I don't need. And I've kind of iteratively gone through and tried to fix something and found that something else is weird. Tried to fix that, something else is weird. I end up with this big, long, complicated function, which I've kind of reduced to lots of a comment here. And yeah, I come to test it, and I don't really know what totally this is doing. I guess the solution here is pretty simple. Figure out what it does and docstring it. So actually go back, look carefully at what it does, think about the problems it's solving as well, and write a docstring that says, okay, so this clean input thing goes through the text, it removes any lines that have no alphanumeric characters, it replaces exotic spaces with ASCII space, maybe it does a whole series of 10 other things. But I can now just, when I come to test this, I can just look at the docstring and go, well, okay, so that's what that's meant to do. Let's write a test for each condition on that, or for each step, or whatever. And I think it's pretty clear why this is now better code as well, because it means that if I'm subsequently debugging a problem in my software which is using this cleaned up input, and I think, oh, hang on, maybe what I didn't do is actually remove the lines with no alphanumeric characters, or maybe it's getting caught on an exotic Unicode space or something. I can go back and look at what the cleanup function is meant to do, and I have, first of all, the docstring telling me what it's meant to do, and then a test that checks it does it. So I think this is now actually better code, as well as being a bit easier to test. A more involved example, I frequently find myself having to jump through a lot of hoops to actually hit the thing that I want to test. So an example which is a toy example, but it's in the sort of structure that I actually hit quite a lot in real code, is this, which is it's trying to count the number of times in an HTML document that the letter X appears in bold. So the basic idea is that we're extracting a certain part of an HTML document and then doing some relatively complicated investigation of the actual content of that. The difficulty of testing this is that if I want to test that the counting is working correctly, the only way I can do that is by setting up a valid HTML document that has the number of X's I want in bold, and then checking them. And for every possible failure condition I have in the analysis bit, I have to set up a different HTML document with different content. Conversely, if I want to test that the HTML parsing is working correctly, if I'm doing something a bit more complicated than just getting the bold bits, then the only way I can actually check that is by counting the number of X's in the return stuff and making sure it's about right. So again, I'm producing complicated HTML documents and trying to check they're being parsed in the right way, using this very, very blunt tool of checking the number of X's in them. And basically the problem with this code is it's doing two things at once. And the solution is to split it into functions that only do one thing each. So here I've split it into two functions. There's one that's get bold text, that takes my HTML document and returns a concatenated string of all the bold text. And the other that just counts the number of times the letter X appears in any piece of text. This is much, much easier to test. I can test my counting X's string on any string that I want with no extraneous structure around it. I can also examine exactly the output from the extraction part and make sure that it's giving me exactly what I think, not just something different but with the right number of the letter X in it. And I think this is also a better way of structuring the code because firstly I have two reusable components. So if I decide I want to do something else with my bold text, I can reuse that component. If I decide I want to count X's in some other sorts of text, maybe I've got something out of a JSON document or something, I can do that. I can also modify either of them without having to worry about breaking the tests for the other half. If I suddenly decide that I want to count Y's rather than X's, in the original code, I'd then have broken every test for the bold extraction. Now I can change that quite happily, and the bold extraction function's perfectly fine. So I'm more able to modify the code. Now, this fragment isn't exactly equivalent to what I had previously, because I do still need to wrap the two of them into a function that actually calls these two methods independently. But this needs far less testing, because it's really not doing anything complicated. It's calling a function, taking the output of it, putting it into another function, and returning the output of that. That's very, if you're using that static type checker, you might even say this doesn't need testing. You can definitely hit it with one or two very simple smoke tests and need absolutely none of the kind of complex logical poking that the individual components need. When these two things are wrapped up in the same function, it's quite often obvious, but another case where you get this is if you've got a constructor on a class and methods, and you want to test the methods, but the constructor's doing something like the HTML parsing. So there's no way that you can run the method without first running the constructor. The solution there is basically don't. Try to avoid doing any real work in a constructor, and this should all work fine. So the next problem I sometimes find is I'm writing a lot of mocks. Mocking is really good. I am not knocking mocks here. And Python has absolutely brilliant features for mocking. I mean, the mocks library is great. But sometimes when I'm writing tests, I'll find that I've got some code that has a thing that I need to mock. And I've written a mock for that, but that thing returns something else, some other complicated object. So now I need to write a mock for the thing that the mock's returning as well. And I've got mocks returning mocks. On occasion, I've hit a point where I've actually written tests for the mocks to make sure that the mocks are doing what I want. And it's all really taking a very long time. So here's a bit of code that does this, that needs testing with mocks. This is sort of from a kind of thing that I will sometimes do. I'm testing out scoring algorithms and trying to investigate their behavior. And one thing I want to know is, if I run a bunch of different scoring algorithms on the same set of documents, can I get some stats about how they behave, what sort of range of scores they produce? So here we're saying, let's take the scoring algorithm, run it on each document and get the range of scores, and then calculate the interquartile range, because that's a reasonable stab at working out the kind of spread of scores. And this is fine code and it works. The slight difficulty in testing it is I now need to write a mock for the scorer, because I don't really want all my tests to depend on a real scoring algorithm. Well, that means that in order to figure out what the interquartile range should be, I actually need to calculate all the scores independently and then check that's correct. So instead I end up writing a mock. And in this case, the mock would be fairly simple. I can write something that assigns a known score to each document, and it's fine. It could quite easily get quite a lot more complicated. If when I find that this is happening, a solution that I often find that helps is to encapsulate complex logic, the logic that you actually need to test properly, or that you need to test in depth, into a function that is passed and returned a simple value. So rather than be passed an object that has behavior that I need to mock, I just pass it values, which are just values which I can set up in my test easily. So to modify the previous code, basically I just pull out the step that applies the scorer to each of the documents, and just say, well, I'll assume that whatever code's calling this has already done that. Just give me the scores. And now we can calculate the interquartile range of the scores. By the way, I've not actually tested and run any of this code, so if anyone spots errors, then we'll just assume that the test suite would catch that. But I can now test and run this code very easily without having to mock anything. I just decide what range of numbers I want to pass in, what list of numbers, and assert what the output should be. So, yeah, this is much easier to test. It's also, I think, again, a more reusable function. Firstly, I could be calculating the interquartile range of some other set of things other than just the output of the scorer. I could apply some transformations to them first. I could have some other set of numbers that I'm interested in this calculating these stats on. And again, also, I don't have the issue that changes to the interface of the scorer. If I decide that the scorer is now going to take a whole bunch of extra non-optional arguments, that this code suddenly breaks, and that all the tests for this code need rewriting to reflect the change in the thing it's using. So I've also got, again, more modifiable, more reusable code. A related example to this, this is really a bit toy, I'm afraid. It's a prime printing thing, and this is classic kind of programming 101 stuff. Yeah, we get given a maximum number. We crank through things in that range, check whether they're prime or not, and then print them if they are. So here again, the difficulty is I need to mock print. This is a thing that comes up a lot in real-world programming, that you end up with not necessarily print, but a database write, or rendering an HTML thing and returning it, HTML document and returning it, or whatever else, wrapped up tightly into your logic code. And again, the solution is basically just don't let the complex logic depend on the I/O code or on other complex systems. So again, we pull out the actual logic into a separate function. The separate function contains everything that is really going to need in-depth poking with a test suite. And then just have a simple wrapping function that requires very little testing, and just applies that function and then prints the output. Again, this is nice because if I'm now in my enterprise prime printing project, and the client decides they want a mobile app or something where rather than being printed, these things need to be rendered and then returned via Flask through a web API, I don't have to go and rejig and extract everything from my listing function. The listing function is just there and I can reuse it. And again, the tests don't need changing in that situation either. So these last couple of examples are about actually getting into quite a lot of big, important, exciting ideas, all of which form more than one separate talk themselves. And the good news is that those talks have already been given. I'd really, really recommend, if you find this sort of stuff interesting, a Gary Bernard talk called Boundaries, which is about the idea of passing boundaries as, using values rather than objects as boundaries, trying to keep your business logic functional, pure code that's easy to test. And also Brandon Rhodes' talk. Brandon Rhodes gave a keynote here a couple of years ago, and was a brilliant speaker. And he does a talk called The Clean Architecture in Python, which is, again, well worth seeking out. Cool. So I guess to wrap up, I think with a lot of this stuff, If you internalize a lot of good practices, then you may not even need to go through this thinking. You'll find that you're writing better code, and your tests are easy to write, and you don't have to go back and change it. And in that case, great. If you're doing test-driven development, you'll probably find that you're getting some of this stuff for free. I believe there's a whole school called test-driven design, which is kind of trying to formalize this idea that if you write your test for your code first, then you'll design your API better because you're thinking about the way that the API is going to be interacted with rather than just writing it and hoping. But if you are having to work hard to write a test at some point, then maybe go back and have another look at the code you're writing and think, am I trying to do two things at once? Have I got side effects wrapped up into the business logic where they shouldn't be? And can I actually make this code both easier to test and actually better? Cool. Thanks for listening.
Thank you very much, David. I think we have time for a few questions, so does anybody in the audience have a question? Okay, I see one back there, hold on.
Hi, have you used hypothesis?
Good question.
And how does it affect what you've just described?
So, I've used hypothesis a bit. That's a very good question. Alex was asking me earlier, actually. I think it probably, I've not really used it enough to be, to say this definitively, and there are people in the audience who know a lot more about it than me, looking at David. But my limited experience has been that at least on the understanding part it really helps, because my attempts to write good, so for people who don't know, hypothesis is, I'm now going to try to give a summary of David's library in front of him. It's a parameter-driven based testing library, which allows you to basically describe, property-based, which allows you to describe a property that you think your code ought to have, and essentially test for a large range of input data whether that actually is the case. And I think, to an extent, yes, particularly the understanding part. Being able to write a property-based test for something really requires you to have a good understanding of what it does. So I've sometimes found that I'm looking at, say, a scoring function, and having thought about it, I believe that there are certain ways it should be monotonic. That if I increase one value, if I give it A and B and A is bigger than B, then the output for A should be bigger than the output for B. So I think on that level, it has helped me to understand the code.
I think we've got time for one more question if anyone's got any. Going one. Oh, yes, back there.
Thank you. How do you draw the line between splitting up a function into testable, reusable parts and ending up with too many small functions that tests are tightly coupled to? Or don't you think that's a problem?
No, that's a very good question, actually, yeah. Like with a lot of things, like I guess with any kind of, anyone trying to tell you, here's a rule that you should always apply when you're writing programs is not telling you the whole story. And I think basically the answer is, yeah, there's just a case of use, taste and judgment and experience. If someone knows a golden rule for that, then they can let me know. But basically, yes, none of this is to be applied kind of mindlessly, but always thinking about what your code, looking at it, is it genuinely better, or am I actually over solving problems I don't really have?
Okay, I think unfortunately that's all the time we've got for questions in this session, but I believe David will be around afterwards if you want to chat.
Yep.
So thank you all for coming to this session. Please join me again in giving one last round of applause for David.